Good afternoon, everyone. I'm Francois Gressier, Director of Capital Projects with ENGIE North America, and I'm based in Houston.
And I'm Rick Kinsinger with Ecosystem Energy. I'm a project development engineer and based in Columbus, Ohio.
Great, thanks, Rick. So today we are very excited to introduce you to this topic at the Ohio State University, which is a project that we have almost completed. It's a centralized heat recovery chiller that supplies heating and cooling to a new hospital tower as well as existing buildings. So today we'll go through the benefit of this project, the challenges that we had along the way, as well as the lessons learned. But before that, I would like to take a few minutes to run through different business models that are accessible to any customers that want to undertake an energy project. So you can see here from lowest transfer of risk to highest transfer of risk, different type of project delivery methodologies. The first one being a design build. So in a typical design build, the end user, the customer, will have a scope of work in mind, and this project will really have a limited timeline. So it will be for a shorter duration, maybe 3 to 5 years, where we'll have to upgrade or renovate energy infrastructure project. But after that, it will be transferred over to the customer. So in this type of contract, there can be some schedule KPIs, some energy KPIs, but I will say that it's limited to the time of construction, design and construction. So there is not much risk that is being transferred at that point. Second type of contract is what we call sometimes ESCO or a standard performance contract. Typically, these contracts are a bit longer in time, so it can be from 5 to 10 years, with specific goals in mind. So the customer wants maybe to reduce their energy consumption by a certain percentage, or have some sustainability targets that they want to achieve in the short term. So they could go through this type of contract, and so transfer a bit more of the risk, because there could be potentially a bonus or penalties related to the end result. If we go down one more step, and that's what we can see more and more in the market, it's called DBFOM. So it's design, build, finance, operate, and maintain. So very similar to the design build, because there is DB, with the additional FOM, so the finance, operating, and maintain. So at that point, the company that was responsible for the design build, and it can be a consortium of companies actually, will also be responsible for the financing and for the operation and maintenance over the life of the assets. So it can be 25 years, 30 years contract. So here, as you can see, not only the customer could put some KPIs upfront on the design and construction, but also during the life of the contract. There is more risk that's being transferred there. And finally, the one that is the most flexible contract that could be thought of today in today's market is the concession agreement, or also called comprehensive energy partnership. So in this one, it doesn't start with a specific scope of work. It's really open-minded. And it starts with actually like a blank page, but projects come up so the customer have a vision, have some goals in mind over the long term, but no specific projects to be done today. And so in this type of concession agreement, it allows for a lot of innovative ideas, a lot of new solutions, and that's what Ohio State University had undertaken with ENGIE Axiom. So now going a step deeper into our concession agreement. There was an upfront payment of $1.165 billion. Duration of the contract is 50 years, 50, which is, very, very long. We started it in 2017, financial close. And we have really 4 main objectives. The first one is operation. Obviously, as you can imagine, it's a large campus, same size as a city actually, and you have like different central plants. So you have heating. We are responsible for heating, cooling, electricity, natural gas distribution within the campus. So we need to make sure that at any time, every building has the utility needed. The second objective is capital. So it's the capital improvement projects. And we have really three types of projects over there. The first one is related to life cycle. So to make sure that we can maintain the existing equipment, replace like for like, and really ensuring that we have a reliable system. Second one is expansion. If the campus wants to expand, wants to construct something new, which we will see in our case here, we'll provide these new utility systems to them. And the last one is actually tied into sustainability, where at Ohio State, we have to reduce the energy consumption by 25% at the campus level for less than $250 million and within the first 10 years of the agreement. And this project, the Centralized Heat Recovery Chiller project, falls into the sustainability project. And finally, on supply, so it's really supply of electricity and natural gas. We are only acting as an advisor, but the risk of commodity procurement lie within Ohio State. So now if I zoom in to the second bullet, which was a CapEx program, and why it's very good in this concession agreement type, is that we really have to think holistically. So you have the full campus where we want to reduce the energy consumption so we can benefit from the flexibility and the load of different types of buildings to implement innovative solutions. So that the process is very transparent because every project that we have on campus has been reviewed and approved by Ohio State. So we know exactly what is going to be built. And obviously with this goal in mind, we are all working towards the same path. So where are we today? We are halfway through the energy conservation program. And we are at about 14% energy reduction, which is on track to reach the 25%. You can see there was a dip that occurred at the end of last year. In 2021 actually, due to COVID and the increase of air ventilation that increased the electricity consumption. But we are working toward mitigating some of these measures that were undertaken in the last few years to really come back to our target and obviously with a desire to even achieve more than 25%. So here what I will just highlight is that the concession agreement framework really allows for acceleration of not only execution, but also overall optimization through this holistic plan. I'm now going to turn it over to Rick, who will be talking about the project in question.
Okay, great. Thanks, Francois. So as Francois mentioned, there were some pretty aggressive energy reduction goals at Ohio State that primarily started for us as the ESCO who was brought in to work on some of these buildings. We started with a demand side approach. So this is just showing how we got building level energy metering. That would be at Ohio State, that would be electricity, chill water, and either steam or hot water. That metering data fed into a building level energy audit, which informed the design of the ECMs, which we developed those with those goals in mind and some of the parameters that were established for this. Once that was approved, obviously that led into construction, commissioning, and measurement and verification. So the area we want to talk about today is in the southwest corner of main campus. It's in the area that Ohio State calls their medical center. And Ohio State, it's important to point out, the medical center is the healthcare offerings, public healthcare offerings it's not necessarily all of the medical research. Some of that is in the academic side. I just want to make that clear because I know different places use different terminology. So what this area we were looking at, just to give you a layout, there is a chiller plant here. Next to that, there's these 3 buildings that are connected together, but essentially operate as 3 separate buildings. The 2 of them are College of Pharmacy, and this one is the Biological Science Lab. Those are all at Ohio State considered part of the academic wing. Across the street, we have the psychiatric hospital and this full-service hospital with everything from emergency room to childbirth rooms and everything in between. We basically pretty early on recognized there was an opportunity here to treat these as more than just individual buildings, as 5 different individual buildings. The reason that we saw that opportunity, so there is all of the buildings inside, they got steam before we got in there. They had steam. They converted all of that steam to hot water for heating. They all already had that infrastructure in the buildings. All of these buildings are larger buildings with a higher level of energy use. Because they're larger, because they have medical facilities in there and research, there's a lot of simultaneous heating and cooling going on. Anytime we see simultaneous heating and cooling, we know there's potential for heat recovery savings in there, and we try to find those and go after that savings. And kind of the point of why we're focusing on this project is to say that with these savings, the whole is greater than the sum of the parts. By putting all of these buildings together in a way that they can share that heat recovery, we get more savings out of that than if we did them all individually and sum that together. So to illustrate that, got a couple of graphics here. As Francois said, the goal is 25% EUI reduction, which is what this project comes in at. That results in this one, it results in a greenhouse gas reduction of over 10,000 tons a year. EUI reduction over here, you can see before and after. The electricity does go up, and I'll get into why that is. But you can see the steam use went down significantly, resulting in collectively a 25% reduction in EUI. Over here, you can see that the heat recovery savings, this is just illustrating that the sum is greater. The whole is greater than the sum of the parts, to use that phrase. This is all 5 of those buildings individually stacked if we were to treat them individually. We get 22% more savings than that by combining them together. Just combining these 5 buildings together. Now, in this situation, we had an opportunity because of the way it was set up. We actually get 64% more savings out of this collective pile because we are taking advantage of it. It's in a district, and there's additional chilled water loads, particularly wintertime chill water loads that we're able to take advantage of. Kind of a one-way street on the heat recovery in that sense, but that helped the overall project with savings. So what did we do? Again, here's those 5 buildings we were showing. Essentially, the short version of what we did is in the chiller plant, we installed a heat recovery chiller that is transferring energy between the chill water side and the new hot water network that was installed. There are tunnels going away from the chiller plant. They run under the street for a ways. We took advantage of some space in those tunnels and ran hot water piping that feeds both of these health center or medical center buildings. there's also, we added this hot water that feeds these three buildings. This is not in a tunnel. It's actually direct buried over to the basement of the first building. And then from there, it's all runs in the buildings. So that we added a new 1,000 ton heat recovery chiller and the other pumps and other equipment in the chiller plant. There were some changes to existing steam and hot water heat exchangers in these buildings, where we essentially got rid of the heat exchangers. And now they're just running on the hot water that's coming from the plant. In the medical center, the end users there really wanted to keep the steam as a backup. So the piping is slightly different. That's what this is showing, that we're feeding the hot water in and kept steam as a backup. And then obviously down here, you can see in the tunnel, I've got a better picture of the tunnel later. You can see there's space in there, and we found a way to run the hot water pipes in that existing tunnel. Here's those pictures. Here is the new heat recovery chiller that went into that chiller plant. This plant was designed for 12 chillers total when it's eventually filled out. At the time we came in, there were 8 chillers in there. So we took up some space for one of those future chillers. Part of what we needed to do was demonstrate that the overall capacity of the plant would not be limited by this project. On the right is a shot of the tunnel. These are large 42-inch, I believe, with the insulation, 42-inch chill water pipes that run through this tunnel. The higher ones on the outside walls are the steam and condensate, and the nice, clean, new white ones along the wall is our hot water piping that we added into this tunnel. So that brings us to some lessons learned. The first lesson learned is, as I said, we were obviously doing demand side projects, looking at building by building, but it's always good to think outside the building. Is there a possibility for additional savings if you incorporate multiple buildings or work them into a zone or build a new hot water district, as we did? Second lesson learned, early stakeholder involvement is key. We had a lot of stakeholders in this one between the academic side and the medical center side and the chiller plant operations side. And we had a lot of people to convince about it. But one of the things we got out of that early stakeholder involvement was we learned about the plans for the new hospital tower, which is now being built, that is going right next door to that existing full service hospital. We learned that in the plans for that new hospital, they were going to incorporate a heat recovery chiller. So we were able to work with their engineers and say, why don't you send that to us? And we can then, again, the whole is greater than the sum of the parts. We can get more savings out of it. And it saved their project the money from installing that heat recovery chiller. Felt like that was a win-win. So that's the third bullet point, is incorporating new construction when possible. Sometimes we tend to think our job is to look at improving existing facilities, but there's always the opportunity with new construction too. Francois?
And to conclude, maybe the last 2 points. So the first one will be, as Rick mentioned, we had to convince initially that it was a good project. And so you could see through this presentation that we had energy reductions, we had carbon savings. And so for each and every project that will complete at Ohio State, we have to get approval beforehand. And so this value proposition needs to be compelling and with concrete benefits to really go through the execution phase. And the last one is, thanks to our framework, so this concessionaire agreement framework. We already have all of the concept laid, such as what is needed for a project to be approved in terms of technical description, what will be the financial return on any projects that will be achieved, and also some sustainability targets. So all of that together really allow for us to act fast. And, within the last 3 years, the first 3 years of the program, we were able to audit almost 20 million square feet of buildings and find more than 20% energy reduction. And so this framework really allows us to execute very fast. That's all we have for today. Thank you for your attention, and we'll open it up for questions.